how you doing? Happy Friday and welcome to this live stream number 66. Today is September 29th, 2017. It's Friday. We made it, man. Hope you had a good week and you are ready for an awesome weekend. Today's topic is understand adaptive clearing and my favorite settings when it comes to that. Now, don't forget, down in the description area, you will find my email address. Any future topics you would like to see on these live streams, make sure you send me an email. See, we've already got people coming in here. Absolutely love it. And if you're watching the recording also, thank you. So, today we're going to talk CAM. So if you're not into CAM, just kick back, relax. We're going to talk about adaptive clearing. Now, this is a topic that I have gotten quite a bit of questions to dive into and talk about. I might actually just change the title to Understand Smarter Toolpaths, because that's really what this is about. Now, if you're already pretty comfortable with adaptive clearing, go to the end of this video if you're watching the recording. Just scroll forward a little bit, because I really want to try to give somebody who are kind of confused about what all this is, I want to give them a good foundation and the best way that I think I can explain what adaptive clearing is. And I think that the best way or smarter toolpath, because we call it adaptive clearing inside of Fusion, inside of Inventor HSM, inside of SolidWorks. And I really feel like that the CAM companies and the machining companies did a horrible job when these kind of toolpaths came out. So adaptive clearing, that's what we got. We got Vortex, it's called on Feature Cam and Power Mill. If you're a Master Cam user, you know dynamic milling, maybe heard of the word. And if you're using something like Gibbs Cam, you've heard about something called volume milling. They all kind of like do the same thing. And the CAM and the machining companies, because the machining companies probably should have kind of like jumped on this one too, I think they really just flopped when they came out with these toolpaths to try to explain what they were. And I think it was because salespeople really didn't understand what it was, and then technical people kind of like tried to overcomplicate it, and it became a roughing strategy. And, you know, when I used to work at Ritlam running the CNC department, if you had come to me and talked about adaptive clearing, a volume mill, and all these other ones, and you said roughing toolpath, I would have been like, I don't really rough that much, so I don't have time to kind of look to that. And that's not what these toolpaths just are. They're actually smart. So that's what I'm going to try to do today. I really hope, because we already got 3 minutes in and we got 30 people, really appreciate it. So again, if you're kind of like looking for the quick and dirty, all the settings, we're going to get to that. That's closer to the end. So just fast forward through all this kind of stuff. So like I said, if you're watching this and you're not using Fusion 360, what we're going to use today, that's fine. But this will kind of like hopefully give you a better idea about what adaptive clearing is, so you can all these other toolpaths, so you can use them better when you're trying to use them. So let's jump into it. So I'm going to get into software in just in a second, but so I think it's important if you're talking about, and I'm going to call it adaptive clearing, but it could be the other toolpath too. I think it's important to understand where about this whole thing started. So when I started in industry and I got a little bit of, gray hair, the place that I took my apprenticeship, they had one CNC mill. And this was kind of like, it was not right when CNC milling came out, but it was, most shops kind of like maybe had one or two. And honestly, back then, CNC mills, you were drilling holes with them. You were not doing all the complex stuff we're doing today. You were really they were just nice because you could drill a bunch of holes. It was really crappy software back then, and crappy controls in the machines too. You couldn't, crying out loud, you had 30 megabyte memory on your PC back then, and that was a lot. That was back when machining within 1,000 was considered really good. So everything else that was machined outside a CNC mill back then was done manually. So Bridgeport style, you crank the handles. You might be lucky that one of the X-axis had a feed on it, so you didn't have to crank the handle with that. But back then, when it came to Feats and Speeds, and we're gonna talk about Feats and Speeds, then back then you really just you had a couple of silly rules, you had a 10 millimeter end mill, and you're like, go with that. And then when it was spinning in the spindle, you would kind of look at it and be like, looks pretty good. And then the feed rate was really kind of what felt good when you were jogging the handle. Now, the reason I'm telling you this is because then when we started using CNC mills for more delicate things, and we started using CAM software, that was kind of what people did. What we did in industry was we took what we knew on the manual machines and brought it into the CNC machine. Garbage truck is compacting right outside my window if you hear some noise. So that was kind of, and when I really started doing some serious milling, I used Mastercam version 6. Version 6 was released, I believe, in 1996. Do you remember what happened in 1996? I looked it up. Spice Girls were on the charts, and Windows had just released NT 4.0. I mean, this is how long it was ago. So let's kind of jump into the software and talk a little bit about what that kind of was. So back then, and by the way, I just gotta jump off topics for a second. Look how you get we're gonna use two models today. Look how the reflection is in this green paint on my model here. Sometimes when I used to work on the shop floor, everything is gray in a machine shop. I always used to kind of throw appearances on my models just so they looked a little bit more interesting. Look at this other model. Fusion has green walnut painted on it. I just think that's funny. Just wanted anybody to throw it off, but you can see kind of the background environment throwing back in this thing. So what happened back in the early 90s, mid 90s, when we started doing CAM, like I said, was we kind of transferred what we did on the manual mills into the CNC. And the CAM companies, they were also kind of trying to figure out how to now run CNC machines with CAM. So if we look at this pocket here on this model, and let me just go into CAM, probably the first toolpath that was ever applied on a mill was probably what we in Fusion call 2D contour. And what a 2D contour toolpath is, if you are from some other software where it might be called something else, is really just, let me select this inner edge, hit OK, is really just follow a line around, right? Hit play here. The tool is just following an edge that we just selected. This is like CAM 101 back in the day, the first thing ever. So when it came to then generate the rest of this pocket, what the CAM companies did was they really just took that line that we just created, and they just kind of offset it in how many times they could offset it in. So if I go in here and do a 2D pocket, I mean, this is still early 1990s. If you go in here and we do the same thing, you will see that all the software does is that it's kind of offsetting this line as further in it can, and it gets to a certain kind of area, and it's kind of start collapsing a little bit on itself. Now, if I go in and I simulate this, it does. This toolpath actually doesn't look too bad. But if I go in here and I simulate this, and let me turn the stock on for a second, and hit play. Actually, we helixing down here, but we didn't even, back then we just plunged down. But what you will see is going to happen let me turn the holder off so we can just see the tool, is right there. Let me turn the speed down a little bit. So look what happens when it comes down. So this is like late 90s. You see how it's using the entire cutter to like go, like it comes down and then the whole diameter just plunges right into the material, right? So when this happened back in the day, you know what you did? You snapped an end mill, right? Like there's just no, and then it just kind of like from there, it's just kind of like offsetting the toolpath out, generally out to come out. So the end mill will snap. Well, that's of course no good. So what we did to kind of like offset that on the shop floor was we decided to do multiple step downs. So we went into our cam toolpath and we did multiple depths. So you would probably do like something like 100,000 depth, or you know, a couple of millimeters down, or something like that. And then you ended up with all these toolpaths. And now instead of breaking end mills, sorry, I'm still getting over this cold. We're still taking this full width of the cutter when it started, but at least now just taking 100,000 step over. Well, then you're at least not breaking the tool, right? Now, what you are doing at this point is you have an end mill that has like a 1 inch long flute length on it, but you're really only using the first 100,000 of it. What means that, you know, at some point that 100,000 is going to wear down, and that's when you kind of like start, you can hear the cutter becomes worse, and you know, it's really not a very gentle toolpath. So that was one of the things kind of like to take into account. The other thing that we were running into an issue, if you look at this model, was the way that the toolpath is calculated. Like I said before, it kind of offsets the contours a certain amount in. So we go in here on this model and we do a 2D pocket, and I'm just going to select the same tool as we had before. Right there. And I was just going to select the bottom. Again, so if I create this, you will see, if you look at all the blue lines, it's just literally offsetting the round edges and the rectangular edge in. And it's trying to then kind of like blend those things together. And then it's trying to find kind of like some safe areas. And if you're looking here, you're ending up with 3 entries. So it literally enters the material 3 places. Now, this always used to bother the heck out of me, right? Like, you're like, why can't you just enter one place and machine around? Well, the problem is because the software is offsetting all this geometry in a certain distance, and then it's got to kind of like find places to put it in. So if we switch over to the same as we did before, that we say that, well, then we're going to do it with multiple depths, because we are we're kind of like running into the same issue that the cutter is cutting with the full width. And then I'm actually just going to change the helix to just plunge. So what you will see when we get here is we will see that when I simulate this, the cutter will, again, pretty much, I hope this is worth, you can see this. The cutter is still kind of like cutting with the full width of the cutter many places. And actually, because of these 3 plunges on the model, it's kind of like, cleaning up those safe areas first, and then it goes around and it kind of like takes care of the extra things. So you see here, it's kind of like cutting with the whole diameter. Now it's going to go to the next depth here in just here. So it cleans out the safe area here, kind of like machining around. Go around here, cleaning this area out, leaving a little bit of stock over here. It's going to come back and clean out. So this was kind of like just, I don't know, a little bit of an interesting way. And that's how kind of, I will say, in the early days, we did a lot of this kind of that's how we dealt with it, right? So it ended up that you have a end mill where you're only using 100,000ths of it because you can't go deeper because then the end mill will literally snap, and you're only wearing that 100,000ths. What means that a lot of people like myself started sending cutters out to regrind, and then they became shorter and shorter, and it's not really the right way. Well, so let's talk about these smarter tool paths, because then, and this was actually in the early 2000s, and adaptive clearing, the one that we are using in Fusion, was actually one of the first ones to come out with this technology. It's going that way back. What happened was that somebody who was pretty smart figured out that instead of just taking that outer edge and offset it in, how many times we now can, and then try to find some safe areas, how about when we know what the model is and we know what stock is defined, how about we letting the cutter use those two informations? It knows what it needs to cut, and it knows the stock size because we defined that. Then let the cutter find a area where it will cut with a constant load on the cutter. So instead of the cutter going down and be fully buried on the first move out, and then maybe cut an area that don't have much engagement, and then hit like an internal corner again, where it like gets fully engaged in material again. Instead, let the tool path figure out a path where it's keeping a constant load on the cutter. So the same load, so it doesn't have these full cuts. So that's what really these tool path does. Now, what that does is that we can now control the step over that it's going to do. We can keep a constant load on the side of the cutter. What actually means that we can cut all the way with the flute length, but then control just the thickness of the side milling. And if you ever tried, you know that side milling is a lot better than slotting, for example. Even if you are on a bridge point, you're cranking handles, you know, slotting through material is a lot harder than just using the side mill. And that's actually what we're ending up doing. So that's kind of like how it kind of works in the background. It knows the stock, it knows the part, and then it's going to figure out to side mill with a constant load. So it will always be the same thickness chip you're getting out. So let's go in and look a little bit about that. So, and in Fusion, I'm sorry, I have this cough. In Fusion, there is kind of two adaptives, and I'm going to show you both of them. There is the 2D adaptive clearing, and then there is the 3D adaptive clearing over here. And I'll show you both. But the settings within them are really pretty much the same. And I hope, and you do the thumbs up, thumbs down here for this video, I hope that from this you will get the settings that will make it more sense for you how to use it from here. So if we look at this standard pocket tool path, let's just go in and look at the cutter here. Whoops. I hit the wrong button. I didn't want to compare anything. I don't have anything to compare it to. One thing I want to show you is the Feats and Speeds for this cutter. So we're going to use the same cutter all the way through. Now, for this cutter, I picked what I would call pretty conservative Feats and Speeds. And you are welcome to comment in the comment area below. But 800 surface feet. This is a half-inch end mill. So 600 RPM, 6,000 RPM, sorry. I'm running 1,000 chip loads. That to me is extremely conservative. Now the lead in here is actually a little wacky. You can of course change that. So let's go back into the tool and let's just select the tool here and edit it. Oh, okay, we had it in here. Okay, I'm selecting the. Never mind. So doesn't really matter, the lead in, lead out. So we're going to use the same tool for both of them. So if we look at this pocket that we just did, the old-fashioned way, 100,000 step over with conservative Feats and Speeds, and we right-click, we click machining time, we have a machining time here about 40 minutes to do this pocket. So that was kind of like how I used to do a lot of this kind of machining is I would just do it the old-fashioned way because, I thought that all these adaptive clearing, dynamic milling were just for roughing, and I maybe don't rough much of material. Well, let's go ahead and do a 2D adaptive. So like the 2D adaptive, I'm using the exact same Feats and Speeds, but it's actually a perfect place to start with your adaptive. So if you've never played with adaptive, just start out with the same Feats and Speeds that you have used so far. That can't go wrong. I'm going to select geometry. I'm just going to select this pocket. So I'm using the same kind of thing in here. And then when we go over to the Passes tab, the only thing you really need to know about in here is this optimal load, where we are controlling that chip thickness. So instead of going 100 thousandths down, we're going to spiral all the way down to the bottom. There's nothing scary about that. That's fine. Then we're going to set this optimal load to side mill. And here we can control how much we want to side mill. Now, I have mine set here to 200 thousandths. That is probably right in a good starting point. But hey man, if you want to be really conservative, go with 100 thousandths. I mean, like, think again. If you were side milling the outside of the block, 100 thousandths wouldn't be crazy. It wouldn't be like insane. So I'm just gonna change it to 100 thousandths. So I'm actually, I think, going way down conservatively. Hit OK. So what you will see if we're just looking at the toolpath right now is, if you're looking at the 2D pocket we had before, I know that we already talked about that we have multiple step downs, but we also had 3 entries, remember? It kind of like enters 1 here and then it had 2 out here. Well, you will see that the adaptive only have 1, and then it's just going to start kind of like doing that movement out from like side milling everything. So if we simulate this, it's going to spiral in. And like I said, there's nothing scary about, I mean, that's better than plunging straight down, right? It's going to spiral in. But then you will see when it gets down to the bottom, now it's really just side milling. There is no, and this is why you shouldn't be afraid of doing this toolpath. It literally just continually side mills that 100 thousandths out that we had loaded up in there. Now you want to have some coolant shooting all the chips out because you are going to create a lot of chips. But what this does from a wear standpoint on your machine is that instead of using, the way I used to do a lot of this milling, and what we used to do when we started out, is we did that 100 thousandths. The cutter would break down, and then the cutter would literally, because if you think about it, the bottom of your end mill and like that corner between the bottom of the end mill and the side, that's a sharp edge. That's going to break down first. And when that broke down, you put more load on the cutter from a spindle standpoint. You had a lot of Z moves every time you went 100 thousandths down, putting pressure on the Z axis and the X and the Y, where side milling with an end mill is the gentlest way you can do it. So that means we're putting less stress on the cutter, but actually also on the machine. So adaptive clearing by itself is not like this, sorry my language, kick your butt toolpath that you need a crazy machine on. It literally just sides mills out. Now, I was using the exact same Feats and Speeds, right? I was doing 100,000 step over here. I was doing 100,000 side milling step over here. So again, if we look at the first toolpath and we right click and we click on the cycle time, machining time, we had 40 minutes. Now, that was kind of like layer by layer. Look at the adaptive. Right click, machining time, we're down to 15 minutes. And this is why the sales guys for the cam companies were saying, oh, this is a great roughing toolpath. Well, yes, it is great roughing toolpath, but it's really just a great smarter tool path from start to end, because that it kind of like works in the way it works by side milling out and never gouts the end mill. So that's where this is kind of coming from. I'm gonna run a little bit over the 30 minutes today, but now we're gonna get into a little bit more about some of the settings and how I think you should approach this. So, like I said, when you start out with your first 2D machining, you should really start out with the same feats and speeds that makes you comfortable in here. Now, your surface feed is many times also controlled about how much spindle RPMs you have, right? But your feed rate, how much load are you going to put on the cutter per tooth? So here the cutter each flute will only take a pressure of 1,000. I would not be surprised if you could go, even if this is kind of like a mid-sized, smaller machine, you can go a lot higher with that. But this is a good starting point. And then in the passes tab, this optimal load is really, how much material, how wide a step over can I go? And what I recommend people do is you should do a little bit of testing on your machine because it's so specific. So again, going back to my story, I remember when I was at Ridlam at one point, and I was fairly new there, but we were really trying to, be efficient. And the owner, John, great guy, was always talking about, how can we work faster? We need to work smarter. And one day, I went into him and I was kind of trying to, I really had to build up my courage. I went into him today. I'm like, okay, I know that you really want to run your machines better. Would it be possible that you could take a couple of hours out of the calendar and maybe take a block of steel and do a little bit of testing to find out how hard can we push the machines? And honestly, I thought that he was going to be like, oh, no, we got to make money. We got to make parts. He was completely in the opposite direction. He was like, yeah, we should actually take a day, just take a Friday, and let's do some testing. Just like if you had a race. I mean, we're all trying to be professionals here, right? And we're trying to run our machines the best we can. And race car teams, they got to go out and test too. And he actually ended up suggesting that we got a couple of cutter manufacturers to come in. And I spent the whole day testing on the machine to start out conservative and then bump up, your spindle speed and your feed rate. And then, with the cutter manufacturers, kind of like what do they recommend and the optimal load. And you can find out with the equipment you have, really, where are you? And if you have a decent machine, like if you have, something that is you would consider professional type machine, you probably be surprised how much you can push the tools with these. But it's also important to say that even if you have like a hobbyist machine, this tool path is still smart. So that's extremely important. So let's go ahead and talk a little bit about some of the different settings that is in there. And it's really not as complicated. If you ever try to get a grab of these, it's really not that hard. So again, I'm using the default settings inside of Adaptive. So again, I just applied this tool path out of the blue. I went in, I selected the same tool, I selected this area to be machined, and I hit OK. We played with optimal load, sorry. So some of the things that we got to talk a little bit about is one of the first things you get these rapid moves, right? You see all these rapid moves in here. And my boss, John, would definitely have looked at this and been like, wow, that's a lot of rapid moves for machining this thing out. The truth is that you can adjust this, but some machines actually rapids very quickly. So to do a rapid moves is really not a bad thing versus maybe trying to stay engaged with the cuts. Now, the way it works, and this is actually pretty interesting. So let's go back into edit. And again, this is straight out. I just selected that surface, and then we played with optimal load. Now, to control those rapid moves, you go over to the last tab, which is the linking tab. And there's a couple of things I just want to show you in here. It's really simple. The ones you should know about in here is the maximum stay down level and this least. Now there's other settings in here, but just worry about these right now. The maximum stay down level. Now this is kind of interesting. You maybe have looked to this and you've read this and you still quite don't understand what this kind of like means. What it means is that right now there's a maximum stay down distance, and then it has a 2.5 inch area. What it means is that if I can move, can I wrap it? Oh, I gotta say it in a smart way. I'll show you in a second. Can I wrap it within or stay down within that circle? So 2.5 inches. Think about it like a 2.5 inch circle in here. It will wrap it if it's outside that area. Let me show you. Maybe that is a lot better to show you. So what I'm going to do is I'm going to take our original toolpath with all the rapid moves. I'm going to right click and I'm duplicate it down here. So now we get one more here. This is totally identical. Now, an interesting thing to know is that if I inspect this square pocket, it is 5 inches long. So it's 5 inches by 5 inches. Now, if I go into that stay down level area and I'm saying I'm going to make it bigger. So I'm going to make it was 5 by 5. I'm going to make it 10. What I'm saying to the software now is that I want you to look for a place to travel safely within 10. But if you are within a 10 environment, a diameter of 10, you can find a travel distance without rabbiting. So I'm going to hit OK. Now, one of the downfalls with this is that it takes a little bit longer to calculate when you do this. Now, right now, when you're looking between the two toolpaths, you will see that nothing has really changed when we're looking at the rapids. But that is where the second option comes in. And that is this stay down level. Now, by default, it's set to the least because that is calculating the fastest. But if I say it to most, then you're telling the software that within 10 by 10 envelope, find a safe place to move to without rapid. Maybe that's how I should say it. So let me hit OK. Now it's going to take a little bit longer to calculate. This is one of the downsides. But look at it now. We only get one rabbit right there versus the first one. I'm going to show you this again in a second. Okay? So that's the only settings you really need to worry about when it comes to this within here. That when you go into the settings, this controls how big an envelope that will work within. So let me go back down and just make it like, if I made it, maybe I'm going to try to make it 3. I haven't tested this out. 3 inches and hit OK. Still calculates. So within an envelope of 3 inches of where the cutter is, it will now do, it still finds that only that one place that it has to rabbit up. So what I normally do when I am doing these is that I normally set this one to a high number, and then if it's a big toolpath and I don't want to wait for it to calculate too much, you might just set it at like 50%. So set this at 10, 50% and hit OK. This is kind of like my normal setting. And you will probably see that now I'm ending up with 2 rapid moves, right? So it's somewhat faster calculating, and we're only getting a few quick, rapid moves. So let's jump over to this part and talk about this one doing, again, I will show the 2.5 axis one more, or the 2D adaptive one more in here, but on that inside pocket. So the same tool, same feats and speeds. Let's just select this inside area. I'm going to set that optimal load to 100,000. Let's be extremely conservative. Hit OK. And you will now see if we compare these two toolpaths, right? So there's was our first pocket toolpath versus the adaptive. Again, notice how it comes down. You can see how it does a side milling till it gets out there. So that's how that will look. If I wanted to try to eliminate some of these rapid moves, now if many times if you don't think there's too many rapid moves, don't worry about it. But if you want to, go into the linking tab, you can change what area you want the cutter to look at, and then you can, in the stay down level, control what happens to it. I'm just going to hit most without changing the default 2.5. And we actually got a couple of less rapid moves. Okay. Now let's talk about the 3D adaptive. So the 3D adaptive really does, I'm going to show that in a second, the shaft holder collision, really does about the same thing as our 2D adaptive when it comes to settings. So same feats and speeds, and we can go over and we can go to the passes tab. We can set the optimal load in here, okay? So we can set that to 100,000 like we did before. Now be aware of down here, the step down in here is automatically set because it's going to go all the way down here. So in default, you will set it about the flute length of your cutter. So if I have a 1-inch flute length, I might just, this is just me, I'm a little scaredy cat, I might just set it to 900 just to be a little bit conservative. Now I'm not going to change those setting over on the linking tab. I'm going to leave those at the default and just hit OK. Whoops. And turn that off. I was in there playing earlier. Now the adaptive, we don't have to select the containment area. That will just rough everything we see, right? Now again, this looks like, if you're looking at this right now, you're like, holy moly, there's a lot of yellow lines. Now again, this is worth testing out. If your machine is really quick and rapid, this might be just fine. But of course, we can always play with those rapid moves if you want to. If I go in and I duplicate this one we have here, and I go into that adaptive and hit edit, let's go back to the linking tab. Again, we can make this big. Now this model is like 8 inches diameter, so I will normally make sure that it's like kind of like this, the area of my cutter. And let's just set this one to, let's just set it to 50%, but it's like my default kind of go out of the gate so it doesn't take too long to calculate. Still going to take a little bit longer to calculate. But what the cutter will do now is, again, remember from the beginning, it is the model versus what stock we have. And it will now find a shorter distance between the next path and not wrap it that much. So now you will see that it's still calculating fairly quickly. It's going a little bit slower than before, but you will see that we have a lot less rapid moves. This was the first one. This were the second one in here. That a lot less rapid moves, right? And of course, if I duplicated this one and we just set that to the max, because you might want to just see that now where you're at it. Click OK to that and let that calculate. So I hope that this is making sense. I really hope that this, and if you joined the live stream late, this is really not about just roughing a lot of material. It's a smarter way to remove because you're pretty much just side milling instead of, you know, the old-fashioned like dig down 100,000ths, slot pretty much with your cutter. The last thing I want to show you, still calculating, the last things I want to show you in here with this toolpath that you might like is, so now we can look at rapid. First one, second one, third one. There's a couple of rapid moves that was eliminated. Actually, but one of the things that you probably would have considered right now is, wait a minute, if you're machining with that little end mill all the way down to here, ain't we gonna get some collisions? And let's turn the holder back on. And yes, we are. That's when we're gonna get all these red warnings right down here about these collisions. I want to show you that inside of Adaptive, there is the option, and you saw I had it before turned on, that you can detect either the tool length that you need, or you can also ask the cutter to stay away from surface, so the holder will not hit this this dome here. So I'm just gonna that's gonna take a little bit longer to calculate too. So really, while that is calculating, really just remember that start out with the conservative feats and speeds that you already are using, that you're comfortable with. In the passes tab, you have that side milling value, and that's really all you need to start out. Then if you want to kind of like play with the rapid moves, there's a stay down level that, you know, the bigger it is, and then you can kind of control the stay down level down here. So let's just see it here. Well, see, now it's still calculating. Now it's really doing a lot of math. While it's still calculating, a couple of more things I gotta tell you. Thank you so much for all you guys to hang around. Down in the description area, I put a couple of links. I put a link to Al Watmore, the product manager of Fusion for CAM. He created a video from Pier 9. So if you are brand new to this whole adaptive, watch that video, because I think he really just, there he actually has the machine cutting, and it just gives you a very good idea. The other one that is down there is my good friend John Saunders, and I actually wear his shirt today because of that. John has a great channel, NYZ CNC. I know a lot of you guys already know John. He have created a bunch of great videos. One of my favorite ones that he did on Adaptive was the one about, what was it called? Stop Slotting the Stupid Way. And actually another friend of mine, Tim Paul, had kind of like him and John had collaborated and talked about actually feats and speeds and step over and those kind of things. So definitely go and check that out. So I just wanted to play this as a kind of like simulation. So again, look at this toolpath. It's just side milling. That's all it does. So if you're brand new to machining, don't worry about it. Take my word for it. Just use these smarter toolpath. If you're an old dog like me, and you're kind of like, I don't know, it's all fancy, and they said it was all for roughing. Well, you know what? It's not. It's really the difference between a fax machine and an email. Constant side milling across the part, and not just moving all the chip. So it's actually better. It's actually better for your machine because it's adding less pressure on it, and it's better for your tools too. All right, guys, I'm gonna leave it here. I really hope that I accomplished what I was hoping for. So for you guys who maybe have a lot more experience and kind of like maybe felt like that you didn't see anything that you shouldn't have seen, if anything, I love your comments down in the comment area if you have any advice for anybody else to share. For you guys who are fairly new to all this, I really hope that I managed and not made it too more confusing, but actually managed to kind of like make a little bit more sense of it. So I hope that this gave you the confidence to kind of like test out adaptive clearing and fusion, or maybe some of these other ones if you're coming from another cam system. I'm going to end it with this. It is Friday. It's almost time for a beer. I'm going to do what I normally do. I'm going to end the broadcast. So if you're watching the recording, thank you so much for taking the time to do that. If you haven't subscribed, I would really appreciate it. Thumbs up if you like it. Thumbs down if you don't. And then I'm going to jump into the live stream and say hi to everybody in there. So, until the next time, have an awesome weekend.